So hello everyone. First, welcome to this Young Achiever Seminar. So my name is Wenbo Zhang, a second-year PhD student in IST Penn State. So in this semester, I'm helping the Center for Socially Responsible Artificial Intelligence organize this talk series. Today is our second talk. We are happy to have Chinasa, fifth-year PhD student from Cornell University, to share her research. Her research interest includes explainable AI, human-AI interaction, global health and information for communication technologies for development. So for today's talk, we will have two parts. In the first section, Chinasa will share her talk at first, and then in the second part, we will have a Q&A session, and we will have maybe about 5 to 10 minutes discussion. So, Chinasa, shall we start?
Yeah, happy to start. So yeah, thank you for the great introduction. And so for this talk, I'll begin by motivating my dissertation research, and then we'll transition into an overview of community health work in the Global South, AI and community health work, and explainable AI. And then I'll discuss the work from the 3 studies that I've conducted throughout my PhD so far, and end with a brief discussion of some future work to round up everything. So let's begin. AI interventions are permeating various industries in the Global South, such as healthcare, education, and agriculture, with an aim to empower underserved people. Despite this proliferation, little work has been done to assess these workers' understanding of AI, how they discern its use, and how they perceive its benefits and implications. In the case of community health work in the Global South, many of these users happen to be novice technology users. One, due to their lack of experience using computers, and also their limited experience operating smartphones. Coupled with low levels of technology literacy, the introduction of AI and frontline healthcare, or just frontline work in general, stands to exacerbate existing biases within AI and also create extra work for caregivers, since they will have to learn how to use AI systems, troubleshoot errors, and explain AI decisions to their patients. These challenges could potentially lead to degraded levels of care for local communities if AI tools are integrated without addressing their needs and concerns. The shortage of qualified medical professionals in many low-income countries has led to the establishment of programs in which community healthcare workers, also known as CHWs, and that's how I refer to them throughout the presentation, they are usually women and are recruited from local communities. They receive basic medical training and then work to deliver essential healthcare services to communities in hard-to-reach areas in the Global South. Prior work has shown that CHWs are essential in delivering healthcare services, resulting in improved healthcare outcomes. Research by Baki et al. Highlights CHWs' roles in reducing neonatal mortality rates in Bangladesh, and Kumar et al. Note how CHWs can positively change healthcare behaviors in India. Other work examining the broader socio-technical implications of deploying mobile technologies has also shown how mobile technologies play an important role in the work of CHWs. These community health workers are likely to be the target users of AI systems that aim to improve the health of marginalized communities, for example, through AI-assisted disease diagnosis and prediction. However, these users still possess little experience with technology, and AI in particular, that stands to threaten how they could potentially operate such systems. Despite research highlighting the role of mobile technologies in frontline healthcare work, not much has focused on AI tools that are relevant for CHWs in low-resource context. A few projects have created smartphone-based computer vision applications to enable CHWs to analyze rapid diagnostic tests, such as work by my advisor, Nicola Dell et al., that monitored CHW usage of essential healthcare commodities, and work by Park et al. That built and evaluated an app to let CHW take high-quality images of malaria rapid diagnostic test. Other work by Yadav et al. Has used a Wizard of Oz design to look at how chatbots may be useful for answering mothers and CHWs questions about breastfeeding. My research contributes to this nascent literature by examining CHWs' knowledge and perceptions of AI, the benefits and challenges that they foresee in integrating AI into their work, and the resulting impact on their workflows and other stakeholders in rural healthcare. My work also introduces the opportunity for explainable AI to improve AI systems that cater specifically towards novice technology users, such as CHWs. Explainable AI, also known as XAI, can help avoid such pitfalls associated with deploying AI with novice technology users. But nearly all prior work has focused on users that live in relatively research-rich settings, such as the US and Europe, and that arguably have substantially more experience with digital technologies such as AI. Thus, there is an urgent need to also closely examine the current state of XAI in the Global South and identify opportunities to make AI systems more explainable for users in these contexts. Popular techniques for XAI include SHAP by Lundberg et al., which is a method that explains individual predictions by measuring how model features contribute to them, and LIME by Hibero et al., which trains surrogate models to help explain how the original model arrived at a particular decision. SHAP and LIME methods are relatively generalizable and have been applied to a wide range of machine learning subfields like computer vision and natural language processing. Anchor, a method that extends the LIME technique, explains individual predictions of classification models and works for text or tabular data. It has also been applied for use in visual question answering for image classification. And other methods based from the philosophical domains include contrastive explanations, which aim to describe event occurrences in contrast to one another, and counterfactuals, which describe events in causal form. Work building upon existing XAI methods has focused on making AI explainable for both users and developers, leading to novel frameworks and methods such as Google's model cards for models and Microsoft's datasheets for datasets. These aim to facilitate human comprehension and increase the transparency of AI systems. Some of this work has also begun to focus specifically on novice technology users, such as work by Shen et al., which aims to understand the challenges the general public has in understanding confusion matrices, which is a tool that is used to convey the performance of machine learning classifiers. Other work by Cheng et al. Has measured the understanding non-AI experts have of an algorithm used for educational decision-making. However, most of the work in this domain has been centered on Western context. My research expands work in this field by centering exclusively on novice technology users in the Global South, more specifically in India, to develop novel tools to improve their understanding of the decisions produced from AI systems. While much of the research presented in XAI has focused on technical and algorithmic techniques, human-centered studies that aim to understand how humans perceive, value, and understand AI have also begun to emerge. To help non-technical users understand AI systems, researchers have explored techniques such as interactive demonstrations, visualizations, and storytelling. These techniques have been used across a range of applications, from helping users improve ML classifier performance through data labeling, to encouraging co-design of AI systems between scientists and local communities. So, as advances in AI lead researchers and tech companies to develop AI applications that target the health of marginalized communities, it is crucially important to study how do community health workers perceive AI and what are the anticipated benefits and challenges. In my first paper of my dissertation work, we present a qualitative study that examines the AI knowledge and perceptions of community healthcare workers in rural India. This work was accepted and presented at CHI 2021. So for this work, we created an exploratory video provocation in which a CHW visits a mother and her sick child. The CHW in the video then uses an AI-enabled application to scan the baby and diagnose him with pneumonia. To encourage balanced and diverse responses, we created two versions of the video: a positive scenario in which the mother embraces the use of the AI application on her child, and a negative scenario in which the mother is suspicious and distrustful of the application. After viewing one of these videos, CHWs participated in a 40-minute semi-structured interview. Although our findings suggest that CHWs don't have much knowledge about AI, they do have opinions regarding the perceived impact of AI on their workflows, communities, and for their livelihoods. However, CHW's low levels of AI knowledge was concerning, given that AI applications that target their work are already in active deployment, and early deployments of these technologies have already reported failures that at best created additional workflow inefficiencies, and at worst, harm the communities that they aim to help. CHWs agreed broadly that an AI app may be able to accomplish some of their tasks, but it would never completely replace the breadth of activities they perform, including consultations, immunizations, and culturally sensitive discussions on breastfeeding and family planning. And overall, we found that this is one of the most, I would say, significant findings from the study, just because a lot of times we see that AI is introduced with the mindset of replacing human work rather than complementing it. So it was good to see that the CHWs understood that they still have a role, in operating AI. So for our next finding, many CHWs felt that having the AI app perform tasks for them would make their work much more efficient, saving both them and their patients valuable time when making decisions about if and when to seek further medical help. Our participants quickly identified that the improved efficiency would be especially useful in rural or remote villages that may be located far away from hospitals or healthcare centers. Additionally, the CHWs felt that this app could be used for training them and solving problems far beyond its capabilities, like for COVID infections, which is really relevant today. So to talk about our main contribution, we understand that all HCI4D, or human-computer interaction for development research, should have a deep understanding of local context. However, AI technologies present new societal risk and complexities that must be proactively studied before attempting deployment. Concerns raised by our findings suggest that CHWs may trust the AI's expertise more than their own, perceive AI to be infallible, and ascribe to AI more capabilities than it actually possesses. These utopian views can have far-reaching consequences if, for example, CHWs act on incorrect predictions instead of challenging them. For this work, we highlight opportunities for both HCI and AI researchers interested in deploying AI with communities in the Global South to understand the challenges of developing AI systems that respect diverse cultural and value differences while ensuring safe and equitable outcomes. So to discuss some of my next work, our paper that I just discussed previously also brought up the need for XAI to cater towards users from non-Western contexts and those with low levels of digital literacy. Within XAI, there's an emerging focus on work that makes AI understandable to non-technical users. With all of this work primarily done in the Global South, very little is known about the state of XAI in the Global South. To understand the scope of XAI in the Global South, we surveyed literature to identify papers that discuss techniques of XAI applied in the development and evaluation of AI. I presented this work at Compass 22 in Seattle last year. Using the keywords and criteria outlined on the slide, we utilized the built-in search functions of the ACM Digital Library, Archive, and Google Scholar. Our searches were not restricted to any specific time frame and were not limited to any specific venues or proceedings. From our searches, we discovered 16 papers highlighting XAI work across a range of focus areas, venues, and regions within the Global South. The majority of papers we found focused on technical implementations of AI and were primarily concentrated in fields such as healthcare or government and policy. A significant amount of the papers we found focused on India, which was not surprising given the high concentration of AI development compared to the rest of the Global South. We also found papers across a range of proceedings, including venues such as CHI and Compass, and workshops at premier machine learning conferences such as NeurIPS, ICML, and KDD. So to go into our findings a little bit more, overall, our research in the fields of HCI4D and ICTD strongly emphasize paying attention to local context when designing interventions for communities. So to develop or analyze XAI tools for applications in the healthcare domain, scholars focused on women sex workers, community health workers in rural India, local communities seeking healthcare services in Colombia, taxonomists, social media users who speak Urdu, and mothers and newborns in Brazil. In education, one paper focused on students and educators in secondary school settings. For misinformation, one paper focused on tweets on socio-political events in India. And within papers that focused on government and policy issues, populations included were women in India from a range of caste, households in the Philippines, borrowers on a loan request platform, and households from 4 East African countries. And in retail, one paper focused on product developers and designers in the fashion industry in India. Encouragingly, we found that of the 13 papers that focused on technical implementations of XAI, all used data from regions in the Global South. And when relevant data was not available, researchers commonly built their own data sets to fill this gap. Such work highlights the additional labor required in generating local data sets that researchers in the Global South and other low-resource contexts may need to undertake when implementing XAI systems. For our next finding, we saw that only 3 out of the 16 papers engaged with target users. In one case, instead of directly engaging end users, researchers worked with domain experts to design an XAI tool to mitigate the impact of mosquito-borne diseases like malaria, dengue, West Nile virus, and Zika. Overall, this lack of engagement is concerning, given the generally agreed upon importance of tailoring solutions to local context and communities in HCI and ICTD research. However, the majority, which is 13 out of the 16 papers in our dataset, used a technical XAI method to develop a machine learning model or to conduct an analysis on data. We considered a paper to be technical if it developed or used an XAI algorithm, toolkit, or library. Several researchers incorporated multiple XAI methods into their model development. While more explanations may be useful to help improve model comprehension, the usage of XAI also brings up concerns around the increased computational complexity of AI models, and also the high computing resources needed to run these models. So to discuss some of our last findings, only one of the 16 papers in our corpus developed an XAI system that was put into practice with real-world users. In this respect of deployment, the researchers noted that data was a challenge at multiple points in the development lifecycle, again, indicating the extra work needed to employ XAI techniques in a real-world setting. The overall lack of deployments seen within our dataset is a bit worrying, but also falls in line with many AI systems not being deployed for real-world use. We also understand that there exists a combination of unique challenges in the Global South, including infrastructural limitations, the lack of AI practitioners, and also a large number of novel technology users. Despite the lack of deployments, a few papers in our dataset also mention future work that is focused on implementing their respective systems. Overall, such progress towards putting XAI systems into practice is an important next step in testing its viability. However, cautious approaches to deployment are needed, especially in the Global South. Our findings show a number of positive trends across existing research that is focused on XAI in the Global South. First, much of the research involves authors from institutions based in this region. Second, the researchers took steps to ensure that their work used data that was local to the context. And third, most of the current research focused on advancing progress in critical domains, such as healthcare, education, and economic mobility, and targeted a very diverse range of potential users and communities. However, Our findings also highlight some concerning gaps. First, the small amount of research yielded by our review highlights the urgent need to advance the state of explainable AI in the Global South. And second, the lack of empirical studies conducted with local communities could also affect how XAI is implemented in these regions. Our foundational work raises concern for the utility of existing XAI methods for AI research in the Global South. This requires establishment of a new sub-area of explainable AI research that specifically explores how to explain AI to people with low levels of technology literacy, along with ensuring that these techniques are computationally feasible in low-resource regions. Our paper discussed some initial directions to make XAI accessible to people in the Global South and other low-resource domains, and we encourage you to check this out further. Making AI explainable can be a viable pathway for making AI more useful in real-world environments and increasing its respective ability to improve pressing social issues. We envision a future of XAI in the Global South that centers humans while acknowledging the specific constraints associated with deploying such systems in regions where access to data, limited computing infrastructures, and low AI literacy are present. Engaging with communities most likely to benefit from XAI through fieldwork and ethnography, and then using these insights to train AI practitioners on the needs of these users could also help align the values of local communities with those of the systems that aim to serve them. While it will take significant effort and collaboration to reach this goal, it is critical that the broader AI and HCI research communities converge on a research agenda that will address existing inequities and actively work to solve them in inclusive, sustainable ways. So, as the potential of AI begins to be realized in frontline healthcare, XAI can be valuable in explaining complex diagnoses. However, little work has been explored in this domain with CHWs, community health workers, who are often the target users of many AI-driven tools in low-resource regions. So, to put all the findings from our prior work into practice, we then wanted to know, how do novice technology users engage with existing XAI methods? To answer this research question, I developed interactive high-fidelity probes in Figma that were partially inspired by the BillyCam app developed by researchers at University of Washington, UW, to diagnose neonatal jaundice. BillyCam is a low-cost system that leverages image processing and computer vision algorithms combined with smartphone cameras to assess newborn jaundice. Jaundice is a condition that causes yellowing in the skin due to elevated bilirubin levels in the blood. Jaundice is a progressive disease that affects lower regions of the body as it increases in severity, moving from the head to the feet. In newborns, jaundice is classified on 5 levels based on Kramer's rule, which illustrates the relationship between the progression of jaundice and its accompanying bilirubin levels. To simplify these levels in our representations, we chose to categorize mild jaundice in the head and the chest, which is outlined in yellow on the slide, moderate jaundice in the shoulders, arms, torso, and legs, which is outlined in orange, and severe jaundice as being represented in the hands and the feet, which is outlined in red. Classifying jaundice in this manner would allow us to continue with the objective of our study, to measure the severity of jaundice in a multi-class classification manner. When building the representations of jaundice in our prototypes, we chose only to provide explanations for moderate and severe diagnosis of jaundice. This not only simplified our field procedure, but would also provide community health workers with an ability to map their respective methods of diagnosing jaundice with that of our prototypes. So after designing multiple iterations of the probes, our next step was to conduct fieldwork to examine how ASHAs, who are also the name for CHWs in India, to see how they understood these methods. My advisor, Aditya Fashista, and lab mate, Dhruv Agarwal, partnered with me for this work. Over the span of 2 weeks in July 2022, We traveled around various field sites in Uttar Pradesh, engaging with 35 ashas and experimenting with a variety of XIM methods, which I'll describe in the next slide. LIME and SHAP are some of the two most popular methods used by AI researchers and developers to incorporate local explainability in their models, especially when designing for underserved communities in the Global South. We thus chose to use LIME and SHAP to explain hypothetical predictions from the probes that I designed to diagnose neonatal jaundice. Even though we suspected that the CHWs may struggle to understand XIM methods, given their low levels of AI literacy, we incorporated these methods into the probes to elicit elaborate responses through interaction with a tangible artifact. The default representation of a LIME explanation uses green to highlight pixels of an image that positively contribute to the predicted class, and uses red to highlight regions that negatively contribute to the predicted class. The default SHAP explanation produces a visualization depicting the original input image as a reference image with the images of the predicted class and other classes following it. On these images in the SHAP representation are squares that highlight how specific features, in this case for images, pixels, contribute to the respective prediction. There is a color bar underneath these boxes with a gradient that ranges from blue, which is a negative contribution, to red, which is a positive contribution, and also indicates their respective SHAP value, which is computed when running the SHAP library. Since the visualizations that were designed for our study were not produced from a trained machine learning model, there was no reference to what actual SHAP values would look like. So we used the same scale that was provided in the reference examples found in the SHAP documentation. So before conducting the studies with CHWs, we organized a workshop with the staff of our partner organization to seek their feedback on the probe and the XII visualizations. Based on their feedback, we made minor changes to the LIME and SHAP representations. First, they were worried that red that is shown in these visualizations in traditional LIME and SHAP methods may confuse the participants, since red is often used in public health messaging to imply danger in the medical sense. Since LIME traditionally uses red to highlight features with a negative contribution, in our case, non-jaundice areas of the body would be red in the default representation. This could possibly indicate to our participants that such areas are contributing to the respective diagnosis of jaundice, which is exactly what we don't want them to think. So in response to this, we changed the red color to gray and the green color to yellow, resulting in yellow meaning a positive feature contribution and gray representing a negative feature contribution in our LIME representations. For SHAP, we changed the red color to yellow and the blue color to green, again resulting in yellow for positive and green for a negative feature contribution. So for example, which is demonstrated on the slide, to explain the prediction of severe jaundice, the SHAP visualization would color the hands and feet of the photo in the jaundice doll in yellow, since these regions contribute more to severe diagnosis. So to conduct our study, we first began by welcoming participants and gaining informed consent to record their responses and take pictures of their interactions with the prototype. We then proceeded to ask demographic questions about our participants to understand how long they've been working as a CHW, their smartphone usage, age, and schooling levels. We also asked participants about their knowledge of jaundice and how they conduct specific diagnoses in their daily work. We then used an iPad Pro to show the Figma prototypes to our participants and provided life-size baby dolls that were colored yellow in highlighter to simulate the process of taking an image of a real-life jaundice child. To help our participants gain an understanding of the prototype, we gave them a demo. And we also began the demo by telling the CHWs that the prototype app also worked on smartphones, but was not fully functional. After this, participants were encouraged to interact with the probe which would display a standard decision of either moderate or severe jaundice, and then an explanation of the decision or prediction that they saw. Once participants came to the standard decision, we interviewed them to understand their comprehension of the diagnosis. And then after the short interview, the participants would move on to the explanation of the diagnosis or prediction, and we would interview them again. At the end of the interaction with the probe in general, we then query them to understand the overall experiences with the prototypes. Due to the ongoing confusion with the meaning of color and the failure of the color bars in our updated Lyman Sharp representations to aid CHWs in interpreting the feature importance, we later adjusted the probe to not use any colors at all. So in SHAP, we replaced the colored boxes with shapes. We use circles to indicate a higher feature importance and squares to indicate a lower feature importance to the prediction. To accommodate this change, we also removed the color bar and instead added a discrete legend with a descriptive title in Hindi. Upon using these shapes, we found that the CHWs started to move away from the jaundice/no jaundice interpretation that was present when the color boxes were used within the SHAP visualization. Since they did not have colors to base their explanations upon, the participants started to use their understanding of jaundice to interpret the visualization. Further, since the shapes did not have a color fill, CHWs could also now notice that the baby's encircled body parts look yellow, and also use this information to guess the severity of the disease. In Lyme, we designed probes that try to depict the same information, but without using colors. In this probe, we outlined the parts of the body with less and more contribution, and then labeled them with text descriptions that were also in Hindi. Where there was some inertia in the CHW's ability to read large blobs of text or boxes of text, once they did, some of them started to form an initial understanding of the explanation. Without having the presence of color that was seen traditionally in Lyme and SHAP, these versions that we created made it easier for some of the CHWs to move towards a more correct understanding of what both Lyme and SHAP intended to explain. Overall, our findings demonstrate that while popular XAM methods, in this case Lyme and SHAP, are not interpretable to CHWs, our CHWs in a study expressed the need for having explanations, one, to improve communication regarding medical diagnoses, and also to increase patients' trust in them, and also patients' potential adherence to medical regimens. CHWs relied on their own knowledge of jaundice and neonatal care to interpret the diagnosis and to interpret the explanations. Throughout their interviews, CHWs also relied on their experiences working with diagnostic devices to arrive at an understanding of how the app may be detecting jaundice. However, there was still a slight disconnect since explanations are typically not provided in most of the medical equipment that they use and other diagnostic tools that they use in their daily work. For them, a thermometer simply provides a temperature, a scale provides a weight, and a COVID testing system gives a negative, positive, or sometimes an inconclusive diagnosis in rare cases. Despite some of the overly positive views expressed about the potential of the prototypes to almost always provide correct explanations, in their view, our participants were willing to express critical views towards explanations that were provided by the probe at many instances. And this also led to some of the design changes that I discussed previously for the probes. However, a big focus overall about the interpretations or representations of Lyme and SHAP was to improve the interpretability of the XAM methods, and many participants actually expressed or stressed that they wanted an explanation of the explanation in this case. Given the context of our work with CHWs, new interpretability methods that give workers reason to question, engage, and think critically about AI can help prevent users from forming false beliefs about explained machine learning models and also provide users with the agency to actively challenge these systems. To understand what socially and culturally diverse users, such as CHWs, need to know to be effective AI workers, and also what technical details should be extracted for them, and what new mechanisms may be able to make explanations understandable to them, we envision a future of human-centered explainable AI that combines participatory design methods into explainable AI development. For this to be accomplished, researchers need to, one, spend substantial amounts of time in the field to fully understand the context, as well as the existing strengths and resources within the community. Second, they should XAI researchers or AI researchers and human-computer interaction researchers should also leverage participatory methods that treat community members as active agents in the design process and development and deployment processes as well. And finally, these researchers need to engage in evaluations of XAI methods in line with end users instead of relying on crowdsourcing from general populations that are present on platforms such as Amazon Mechanical Turk. So this work is currently under review and expected to be published later this year. Okay, overall, the goal of my dissertation is to study and improve how AI systems can be made explainable for novice technology users situated within low resource environments throughout the Global South, with a focus on frontline healthcare workers. While there is much progress to be made within this domain, there is much promise for a new era of explainable AI methods that meet the needs of diverse users globally. Thank you so much for attending this talk, and I'm happy to take questions.
Thank you for Chinasa's talk. So next will be our QA session. So today we have we're happy to have Mengqi and Yunan to be our responder who will lead this discussion. So shall we start with Mengqi?
Yeah, sure. Hi, Chinasa. You can call me Maggie. Thank you so much for this amazing talk. I really enjoy, and I agree with you, this is a very important work because despite increasing research regarding, explainable AI, there's still little research that significantly devoted to the understanding of vulnerable or marginalized or underrepresented population regarding how this group use and understand AI-based technology. And this is concerning because these populations are those that are more vulnerable towards AI biases and fairness issues. And I think all your work is a great example in terms of how we should approach this problem. And I'm especially intrigued and inspired by your point about, the importance of doing field work to build a real human-centered explainable AI model. And one thing I found really interesting is one of your findings about how this community workers' level of trust with AI system is they tend to overly trust AI system, right? And this is interesting because when I read some articles about XAI that are done in the Western context, one theme is this health workers, they don't trust AI, they don't want to use it. But here we find really contradicting results in the Southeast countries, and we will never know that if we don't do research with those populations, right? And another thing I found interesting is when you mention some of the most popular XAI method is actually not very easily to be understood by populations from Southeast countries. So yeah, so I think overall I learned a lot from your talk, and should I leave a question now, or maybe we can move on to Yonam to give her reflection on this before we go to Q&As?
Yeah, that sounds good to me. Whatever way is best.
You can ask a question first, Maggie.
Okay. So yeah, I'm just curious about, in general, I'm just very curious about some of the pain point. Do you have any pain point that you discovered in the research regarding people in the Southeast countries that Southeast country that you find are really different from the Western context? And this is probably a challenging questions because we are trained within the Western countries, and we approach the problems based on some of our assumptions. Like, what is the best way to investigate some of the issues that we never thought about would happen with those type of workers?
Yeah, so I think one of the biggest pain points, just in my experience throughout this study, was actually translating the language that is commonly used in these machine learning or explainable AI like tech toolkits or frameworks to Hindi. And so, for example, when my lab mate and advisor are Indian and they speak Hindi, we were translating like things like prediction, and in some cases, like the closest word, for example, was like a guess. But in a mathematical or statistical sense, prediction is not a guess; it's based, on information and data. And so we had to reword a lot of some of this vocabulary or terminology and other things to find the best example. And even in the field, we had to revamp things because the community health workers still had that respective disconnect. And then I would say just in general, you mentioned this in terms of the Western world, seeing doctors are not trustful of these systems. And I think this is due to in part that even though, they may not be considered AI or, experts in this case, they still do have a reasonable knowledge about it. And the major difference that we see in the Global South or in India in this case is that while a lot of our participants had experience with smartphones, they were usually their experience with it was just, using WhatsApp or, maybe taking pictures of their diagnostic charts and uploading it into mobile healthcare applications. But there's no really other extensive use of technology besides that. And for example, none of them had experience, maybe one of them had experience with laptops in general. And so I think this is the big disconnect that we also see. And so within the paper, we mentioned maybe needs to be an effort to improve the inclusivity of AI and machine learning terminology, and then also, ways to actually train people to understand predictions while also creating, explanation methods that are much more simpler, but still convey, a respective amount of information depending on the respective knowledge or background of the user themselves.
Yeah. That's a great point. And maybe should I continue to follow up on that? I'm also curious about how we're gonna communicate to the potential vulnerability of the system. In other words, there's all hypes about AI and all that, especially probably in marginalized countries when they think that we can use AI to help with health work and all that, but we all know that AI is not 100% accurate, and there can be, especially for those type of people, we might experience biases that are very common probably among those populations. Do you investigate this type of issues with your existing work, where you're going to investigate in the future about how to communicate those type of potential biases of
Yeah, so interestingly enough, we did have a lot of mixed responses, with the majority of them, I would say leaning towards more positive or utopian views of AI. But in both of our studies, we did have participants say, for example, sometimes my scale doesn't work, or sometimes my thermometer doesn't work. So I know that AI won't work all the time. So I think it's really just trying to, map basically the domain knowledge of these users, to AI, so they can understand these respective connections. And it was really interesting just to see how those specific examples were brought up throughout my research. And, people, to a certain extent, can understand that AI, may be infallible, but a lot of times I think, I know in my first study more so, and also the third study as well, and that the community health workers are kind of seen as, they don't necessarily have medical training, so they don't get formal medical training like nurses do or doctors do. And so sometimes patients may kind of dismiss them. And so since people see this shiny AI tool or technology, then it kind of reinforces the fact that the community health workers know what they're doing. And then also some of them said, okay, if the patients see this fancy tool that we're using, then they're going to, adhere to, their malaria medicine, their pneumonia medicine. And so we know this will like improve healthcare overall. So it's a very mixed bag, but I think, again, overall, just like using domain knowledge is really important. And to understand the domain knowledge, you have to go to the context, like we did, and do field work and other methods. So yeah.
Thank you for your answers. Oh, sorry.
Oh, yeah. So Sanjana, so do you have questions?
Yeah, I just wasn't, yeah. So again, thank you so much for your wonderful talk. It was so informative, and it's really great to see this work being done because, as you said, it's so important to make sure that the people who really need these kinds of resources the most are gaining access to them in meaningful ways and not just, we made this thing, here you go, have fun figuring it out. But one of my question is related to, I was thinking about kind of building on Maggie's question about the difference between a Western and global South context, and one coming from a like semi-global South background myself, I grew up with like traditional medicine, like Ayurvedic, and like there's traditional Chinese medicine, which is often practiced in these like rural contexts that's very non-mathematical driven, and in my experience, very driven by feelings and like sensations, which I was wondering if there's been any consideration of how these technologies and maybe their analysis and quantification of health has fit into that perception, and if there's any consideration of how these might support traditional methods rather than shifting away, like, because the traditional method does have a place, right? I think sometimes in these places it can be seen as less credible or less valid than what we see in the Western context of medicine. But yeah, if you could just speak to how that balance is struck and if you've encountered any of that in your work.
Yeah, so honestly, I can't say that I've encountered the use of traditional medicines. I know that again, like you mentioned, it's very commonly used. A lot of times the community health workers, they receive training that is kind of outlined by the World Health Organization and other like large non-governmental entities and for example, the World Health Organization has this protocol called IMCI. And so essentially it kind of gives you a table or a chart to track. So like, if the baby has this symptom, you go here, they have that, another symptom, you go here. And so it's kind of a very strict regimen. And then also it's accompanied by like specific medications or, vaccines that should be distributed or, given to patients as well. And honestly, like from my review of these materials, I reviewed it mainly when I was using it for my first study, trying to understand like how is pneumonia diagnosed. Honestly, I didn't really see, like non-Western medicines or not to say non-Western, but like, just like traditional medicines involved like in these processes as well. So I definitely think, it's an open area of investigation, and I can see how that can, play a big role in improving like AI mediated healthcare.
Thank you.
Yeah. So I have a question as well. So first of all, like, thank you so much for your impressive talk. So we see like a lot of talk about or the papers about explainability AI, but we haven't seen like many papers which is talking about the global South or regional issues. So you really pinpoint to really important questions. So, and you also mentioned that like even community health workers, they do really want explanation about the explanation. So I'm just curious about your future research direction. So do you think like there's another method for the community health workers, or as you mentioned, like how like you're gonna considering like community health worker another agency for the interaction. So I'm just curious how you will gonna resolve the issue and then develop your study.
Yeah, so I'm very interested in pursuing this next line of work. And so more so basically we saw that visualizations were very helpful overall in conveying relevant information to our CHWs, even though they necessarily could not interpret it fully. But also, I think the explanations for explanation parts kind of comes in finding or surveying existing methods to understand what things are done to convey, like, very jargony, I guess, text or phrases into more layman's terms in this case. And so there are a couple of, I don't think there are any explanation or excuse me, XIM methods that do this specifically, but more so there are like visual question answering methods or like NLP based methods. One I refer to often is called InterpNet. So basically it kind of provides reasoning for an explanation in text format. And so I think combining like basically creating multimodal explanation methods that combine like both visualizations and this kind of layman's text will be basically like the ideal format of these kind of more user-centered explanation methods. But also, like, again, we come with the caveat in terms of that, AI and machine learning terminology is mostly based in English. And so there's going to have to be a lot of work, to translate to a lot of different languages. And, within India, it's a very diverse country and, hundreds of languages within it and dialects as well. And so that's, and then just across the global South, you have that issue as well, if you want to use these kinds of, AI tools and work. And so it's kind of like a multi-step process. But I would say for me, the first thing is exploring the multimodal visualization plus text explanation methods, and then just iterating and going from there. So.
Okay, yeah, thank you for your answer. It's very helpful.
Okay, Sanjana, go ahead.
It's me again. I just have another question. So thanks again. But so my question is, like, you mentioned like a lot of the low literacy stuff of people kind of just using WhatsApp on their phone, and like your discussion of the importance of colors and that being confusing to people from a low literacy background. But I was just kind of thinking, like, I'm wondering if those obstacles might be present in a Western context as well. Like the language barrier does seem like a very unique element, particularly to the Indian subcontinent due to its diversity of languages spoken. But I was wondering if you foresee any other obstacles unique to the global South that would not be found in a Western context, because a lot of low literacy work has been done in Western contexts, but I'm wondering how much of that translates over and how much beyond the language barrier is there to do. I mean, yeah, so if you could just speak to that.
So I guess, the interesting part about, this work is, well, some parts of my work in general, that it generalizes broadly to problems in healthcare and then also to problems in low resource domains, like no matter where they are situated. And so I would say the most specific, I guess, issue or challenge that we see in, let's say, like the global South context, or let's maybe generalize to low resource, is that, there's work coming out. I haven't been able to find like super definite, like maybe a big corpus of work in this aspect that shows, like adding explanations also increases the computational complexity of models. I've only seen like a couple papers on this, but that's really just the biggest issue, because these healthcare workers will be running, these models or these systems on their phones. Like they're already using like basic smartphones for data entry, and again, just trying to understand how these models, like if they're going to be cloud-based, then you have to, deal with having a solid connection. If they're going to run on device, then you have to understand, how to make these systems computationally feasible. So like, if it's not going to work, then, ASHAs will get frustrated, community health workers will get frustrated and not want to use this app at all. But actually surprising, like when we were in the villages that we visited, India has a really strong like data penetration. And so that was actually like surprising on my end, because like I'm up in Ithaca, New York, and sometimes like my service is really bad here. So that was like surprising to see in a good way. And so I would say like the computational challenges, which is not like, my main field of work, but I think those are something that's something that has to be addressed as well. Yeah.
Yeah, I can definitely see how that generalizes to the low resource setting, like anywhere, because like you said, even in Ithaca and like even like rural Appalachia, which I know people here in IST are doing work on. It's like, yeah, that problem might persist into those regions as well, but it's still important to make sure that the people, again, who need it are able to access those tools. So thank you for that comment.
Most definitely. Yeah, thank you for the questions.
Is there any other questions from other guys? Okay.
Maybe I can ask a question if we have a time. So Chinasa, what takes you to India so very often for all your research of all the places in the global South?
I see. Honestly, I think it's been really convenient because of my advisors. I'm not sure if you know them, but Aditya Vashista, he's Indian. He does a lot of his work in the Indian context. And then also Nikki Dell. She's actually from Botswana, I believe, or Zimbabwe. But she did some of focus her work basically in Sub-Saharan Africa and mostly in India. And so they already had these contexts. They had these connections, which is like really important, and established relationships with partners, especially Aditya, our healthcare partners. And so I think it just became convenient to, study in this region. And also just when thinking about ICTD research in general, a lot of this work has been centered on India, and thinking about like the tech industry, it's, India is seen kind of like as the first stop in emerging markets to kind of as a test bed. And I actually like I want to mirror that in my research, but like, in a more ethical way, of course, because I actually happen to be Nigerian. And so I would love to see a lot of this work transfer over to Sub-Saharan Africa, in other regions throughout the global South as well. So, yeah.
Thank you.
So is there any other questions? Okay. So thank you again for Chinasa's talk today. So one last thing is that for our next talk, we will have Lily Xu from Harvard University. So her research will focus on AI for social impact. Her talk will be held on March 23rd. If you are interested, please consider attending. So thank you, everyone.
Thank you again. Bye.
Yeah.
Thank you.
Bye.
Thank you.
Thank you.